Consider the quadratic. This quadratic is in the standard form ax squared plus bx plus c, where a equals 1, b equals -4, and c equals 3. Let's plug these values into the slots and follow the flowchart. Let's start with the left branch. Invert the sign of b and place it in the numerator. Multiply a by 2 and place it in the denominator. Now, divide 4 by 2, square the result and write it down here. And bring that same value down to the bottom slot. Now for the right branch, place c in the numerator and a in the denominator. Divide 3 by 1 and place the result in the next slot. Now subtract the two numbers inside the center box and place the result in the next slot. Take the square root of 1 and place the result in the next box. Last step. First, add the two numbers together and write the result in the final box. And then subtract the second number from the first to find the other result. Amazing! The numbers in the final box are the roots of the quadratic equation. Let's look at another example. As shown by the numbers in the slots, the quadratic expression is 2x squared minus x minus 1, which has the roots 1 and -1/2. Let's follow the steps of the algorithm to verify the result. Invert the sign of b to get 1 in the numerator. For the denominator, 2 times 2 equals 4. Next, place 1/4 in the bottom box and place its square in the top box. Now for the right branch, place c in the numerator and a in the denominator to get -1/2. Place the number in the next slot. Next in the flow, place 1/16 minus -1/2 into the next box, which equals 9/16. Take the square root. Final calculations. First value, 1/4 plus 3/4 equals 1. Second value, 1/4 minus 3/4 equals -1/2. And those are the roots we mentioned at the start. The question someone might ask is, does this formula work in every case? What happens at the point where we need to take the square root? What if there is a negative number at that step of the algorithm? The short answer is yes, it works. Let's look at an example. Let's look at the quadratic expression, x squared minus 2x plus 2, and apply the algorithm. Place the coefficient values into the slots, and let's get started. Place 2 in the numerator and 2 in the denominator. 2 divided by 2 equals 1, so place 1 in these boxes. On the right branch, start with the fraction 2 over 1. We end up with -1. Now the square root of -1 is the imaginary unit, I. Finally, the roots of the quadratic are the complex numbers 1 plus I and 1 minus I. The amazing thing is that this algorithm works for any quadratic expression, even those with complex coefficients. It's worth noting that while the underlying logic was known in antiquity, great credit goes to this gentleman for presenting this simple pedagogical approach as a brilliant alternative for the classroom. If you enjoyed this video, don't forget to like, share, and subscribe. Thanks for watching.